Welcome back to another installment on functions and linear equations. Let's get started. In the first problem, you're asked to determine the value of x and y. Okay, so here's how you do it. So we have two expressions, y equals 2x plus 4, and then you have x minus y equals -1. There's probably more than one way to do it. I'll just show you one of the ways that you can use to solve the problem. So I'm just going to convert the second expression in terms of y, which would make it negative y equals negative x minus -1, right? So now we have two expressions, y equals 2x plus 4. Then we have negative y equals negative x minus 1. You can simply substitute y equals 2x plus 4 into this expression, which would make it negative 2x plus 4 equals negative x minus 1. So negative 2x minus negative 4 equals negative x minus -1. So if you add plus x on both sides, it makes negative x minus 4 equals -1. If you add plus 4 on both sides, negative x equals plus 3. So x equals -3. Knowing x is -3, you can determine the value of y. So negative y equals negative of -3 minus 1. So that's plus 3 minus 1 is plus 2. Negative y equals plus 2, so y equals -2. So the ordered pair is -3, -2, and that is the correct answer. So 1/2, let's go to the second problem. 1/2 x plus y equals 1. You have negative 2x minus negative y equals 5. So to make your life easy, just multiply the top expression by 2, so you can eliminate any ratios here. So that will make it x plus 2y equals 2. Now we have the bottom expression is negative 2x minus y equals 5. You can multiply, this would be 2, yeah, that's correct. So you can multiply the top expressions by 2. Let's see. Yeah. So you can do one thing, which is x equals, you can further simplify this as x equals 2 minus 2y, right? So go ahead and substitute that in place of here. So that means it will be -2 times 2 minus 2y minus y equals 5. So -4 plus 4y minus y equals 5, right? So -4 plus 3y equals 5. So 3y equals 9, y equals 3. So knowing y equals 3, you can solve for value of x. So negative 2x minus 3 equals 5, negative 2x equals 8, right? X equals -4. So x plus y would be -4 plus 3 is -1. Right? Easy. So here we have 2x minus ky equals 14, and then you have 5x minus 2y equals 5. For what values of k will the system have no equation? What that really means is, that means we are going to say that when the two equations are equivalent. In other words, first let's convert each of the equation in terms of y, so we can have a slope. So negative ky equals 14 minus 2x, right? So y is 14 over negative k, and then we're dividing by negative k throughout, so that will be plus 2 over kx, right? Similarly, let's convert this expression also in terms of y. So negative 2y equals 5 minus 5x. So y equals -5 over 2 plus 5 over 2x, right? So if you say that the two equations are equivalent, then let's say the two slopes are equivalent. So 2 over k equals 5 over 2. So 5k equals 4. So k equals 4 over 5. Essentially, we're comparing the two slopes for a system to have no solution, right? So let's go to the second problem. Second problem, which of the following system of equation has infinite many solutions? Is a system of equation has infinite many solutions when the two equations are equal. That's the condition, right? So which of the two equations are equal? Well, clearly x plus y equals 1 is not equal to x minus y because these are 2, 1, right? These two intercepts are not equal, so these two equations cannot be equal. These two intercepts are equal, but the equation themselves are not equal. It's not same as 3x minus 2y. So this is out of the question, which makes only this is a likely candidate, but you see that the intercepts are different, but we can make them the same. That is, if you simplify this further, that is, get it out of the ratio form, then if you take 6 as a common denominator, it's 3x minus 2y equals 1, or 3x minus 2y equals 6, and the other equation is also 3x minus 2y equals 6. These two are equal, therefore system of equation has infinite solutions when the two equations are equal. That's how you solve that problem. If the system of equation has no solution, remember we said that, so that means we're trying to compare the slope so that we can solve for a dot b. If the system has no solution, that means slopes are equal, right? That's what we did in the earlier problem. So let's convert both of these expressions into the slope intercept form. Okay, so that means negative y equals negative ax, or y equals ax. That's this expression right here. Okay. Similarly, negative by equals 1 minus x, right? So y equals, if you divide by negative b throughout, negative 1 over b plus x over b, right? Or this is same as y equals negative 1 over b plus 1 over b times x, right? The slope here is a, and slope here is 1 over b. The two slopes are equal, so a equals 1 over b, or a dot b equals 1. So the answer is 1. Okay. Again, for what value of a will the system have infinitely many solutions? Again, you want to convert, you want to make sure that the two equations are equal. That is, there should just be just y on each side. Then you equate y because we said the two equations are equal, right? Then we can determine the value of a, right? So let's do that. So 2x minus 1/2 y equals 15. If you multiply by 2 on both sides, then it makes it 4x minus y equals 30. So negative y equals negative 4x plus 30. So y equals 4x minus 30, right? So one of the equations. And the second equation is ax minus 1/3 y equals 10. So 3ax minus y equals 30. So negative y equals negative 3ax plus 30. So y equals plus 3ax minus 30, right? Because the two y's are equal, then we can say 4x equals 3ax, x cancels out, 3a equals 4, so a equals 4 over 3. So when a equals 4 over 3, the system of equations would have indefinitely many solutions. Does that make sense? I know these problems are rather lengthy, but there's no getting away from it. So thank you for watching. I'll see you with another video on functions and linear equations. Until then, bye.